All right, welcome everyone. We're starting to get some people uh, coming on in to the webinar. We'll start in a little bit just to make sure that we have time for everybody to trickle on in. But thank you all for joining. I'm very excited to be able to talk about some of this stuff and love to hear any of your questions. So yeah, we'll give it a few minutes and then we'll get started. I would say while we're waiting for folks to come on in, familiarize yourself with some of the UI here for our little webinar. If you have anything that you would like to ask, feel free to throw that in the Q&A. There is a chat bar. There's a chat that you can use. I would say try to keep all of your questions in Q&A, and any of the banter or comments that you might have along the way, you can throw those right into the chat then. I'm seeing we got a few familiar faces. We have Diana, we have Bruce. Hello, everybody. It's great to see you all. Oh, wow, we are from all over. Yeah, why don't you all throw in where you're calling in from? So we got some Brazil, Bolivia, Michigan. Oh, wow, we are from all over. Ireland, Italy, Dominican Republic, Mexico. This is this is wonderful. Cool. All right, we'll give it one more minute just to make sure that we are good on people rolling on in. Do some housekeeping before getting started, but yeah. All right, just to make sure I'm being conscious of time, we're going to get rolling here. But welcome everybody to our webinar. Before we get started, I'll give you all a little rundown of some housekeeping items. This is being recorded, and all of the slides and material will be available afterwards. So if there's anything that you missed, anything that you want to go back and watch, don't worry, we'll be able to share the link to the video. There are going to be some resources in this presentation that you might want. Again, if you don't get the link in time, don't worry, we're going to make sure that they're included in the follow-up email, so no worries over there. Again, if you have any questions, put them in the Q&A. I'm going to close some windows over here. But yeah, we're going to be talking about Ionic versus the rest. It's a very fun title, but we're really going to look at the cross-platform landscape and kind of evaluate where not only does Ionic stand in comparison to other popular technologies, but how all of these technologies compare against one another. Now, don't think of this as a Ionic versus X or whatnot. This is less about one tool being the top tool, but helping you find out what choices you need to consider when starting your next mobile app. I'm Mike Cardington. I lead up our developer relations program here at Ionic. If you have any questions, I'm basically everywhere on the internet as M. Hardington. Or you can just leave your questions in the Q&A for the webinar. So we're going to start off with the concept of cross-platform development. It is not long ago that the idea of building things cross-platform was kind of a frowned upon idea. We had a lot of people who said cross-platform development is never going to replace pure native development. It's never going to replace everything. But that is a pretty bad, it's just not correct. Like, it's a pretty poor thing to say when cross-platform development is everywhere. It is in our video game industry where I think they are the industry that first kind of took the idea of write once and deploy for everywhere from a single code base and really took it to the extreme. Because if you think about the type of environments that they work on, PlayStation, Xbox, Switch, Steam, all of these different environments have specific requirements that each team needs to take into consideration. And for them to have a dedicated Xbox team, a dedicated PlayStation team, it just doesn't make sense financially. And it doesn't make sense for the team that they are trying to build and the skills that their team might have. Now, popular cross-platform tools in the video game space, you have your Unreal Engine, your Unity. We have this one over here to the side of the screen called Solar SDK for making 2D games for mobile and in Lua. So you have your full 3D high fidelity graphics to your simple side scrollers that all can be deployed cross-platform. Now, for the mobile landscape, we have a wide selection of tools as well. We're going to look at 3 of them today. We're going to look at our React natives, we're going to look at Ionic, and we're going to also look at Flutter and try to see how they all compare to one another. And the best way that I can think of taking all of these tools and comparing them is actually looking at different aspects of each of these tools and kind of seeing where do each of these tools concern themselves with. Now, what do I mean by concern themselves with? I've broken this down into several little sections for React Native, Ionic, and Flutter, and I'm going to look through how do you get started? How do you start writing code? How do you start building out features and adding third-party libraries, accessing native features? I've broken down to these 8 sections, which help me navigate the process of I'm starting a React Native app. What do I need to know? How do I start doing things? And how do I actually ship something? So in interest, if you want to take a screenshot, grab some of the links, again, the links will be available in the follow-up email. So all the source code that we're going to look at today is actually already up on GitHub. You can take a look at all of the code, how I wrote it, what are some of the things that I did, some of the choices I made in that project, and kind of use it as a proving ground for yourself. So without further ado, let's dive into React Native. And before we go into some of the slides, let's actually take a look at the project. So I'm here in my terminal. I have a device emulator opened up. And I'm going to actually just deploy this app to my emulator by run iOS. And this is going to use a couple commands to build my app, get the dev server up and running, and then deploy that to the simulator for me. Now you can see we have a few different things going on. We're compiling a bunch of native dependencies, a bunch of native files. We're getting all of our app up and running. And in a moment, we have our app building and deployed on our iOS simulator. Now this app does something really simple. It is literally just a note-taking app. You can say, hello, webinar. We'll select all that. We'll wait for the little text controls to disappear. We'll make it bold, and then we'll save. And you can see we have a note. We have this really nice ability to present a kind of modal or an overlay. We can open these things and do swipe to delete items. And to make this all possible, we have a simple React Native project. Now, we're using TypeScript in this context, so that shouldn't be too unfamiliar to folks, but we're pulling in some dependencies from the React Native ecosystem. We're pulling in the components that we want to load. We're creating our navigation instance, and then we're going ahead and creating a set of screens that we want to be able to navigate to. So for instance, we have our notes, which is our home page, and then our details page where we are actually going through and being able to interact with that single note. So if you notice, we can click on this note, we can make changes to it, and then have that persisted to our device's file system. Now, how that works is we're going in here, we will look at the editor component for this. We are using our editor. We're bringing in some more dependencies. We have some utilities from the actual React Native library. We're bringing in this third-party dependency called React Native Pell Rich Editor, and then this file system library from the Expo file system. Now, all of this is using some standard React conventions. We're bringing in some states. We are checking the URL params and then reading the file. And then when we want to read the file, we're actually going ahead and calling file system read as string async, giving it the file URI or the path that we want to load from. And then we're going to set the state to that file content. So all of this is, a React Native project in the most basic sense. We're not going through here and building something that is so basic it doesn't show any functionality. We got a little bit of functionality in here. So our React Native project is up and running. We have navigation, we have native API access, we're bringing in third-party libraries. Let's dive into this. So for the uninitiated, React Native is a declarative API around native controls. Basically, all that means is that there are controls inside of iOS, inside of Android, that actually can be used to represent an image, buttons, text, what have you. React Native tries to provide a JSX approach for saying, I want to render some text and have it work for both platforms. So you are using JSX for all your authoring of components. And then it really popularized this idea of learn once, write anywhere, which is that they understood each platform has some differences between iOS and Android. Instead of trying to go through this approach where people try to make everything work and putting in a lot of engineering hours to do so across all the platforms, they said, why don't we give you hooks and ways to be able to say, I know that I need something that's specific to iOS and specific to Android. How can we give you a way to opt into this separate approach, but still have some kind of compatibility layer? Now, to get started building with React Native, you actually have two choices to make, and these are really going to influence your entire production, right? You could say, I want to use vanilla React Native. Give me the basic project, no additional features, no additional tools, and you can do that. Or you could use this community project called Expo, which builds on top of the core React Native experience to give you some additional benefits and additional functionality out of the box. So if you're going to go down this React Native approach, you might need to figure out which one do you want to use. In my case, I wasn't sure what I was going to need and what kind of extra functionality I would want. So I just went ahead and used Expo. Inside of Expo, once you get started, you're presented with a pretty nice simulator experience where you can just run your dev server. You can go ahead and say, open up the Android simulator or open up the iOS simulator, and then deploy to that device, and then be able to start modifying some of your code. Now, out of the box, React Native gives you JavaScript, plain old JavaScript, the one that we know and love. But I'm a huge fan of using TypeScript for everything. So if I want to use TypeScript, the good part about using something like Expo is that it's pretty easy to adopt that into your project. You could just create an empty tsconfig file, and then on your next Expo start, it'll actually go through, inject all of the compiler options, all of the things that React Native needs in order to make TypeScript work. Then, as your team kind of adopts TypeScript into your ecosystem, you can just start renaming some of the files from .js or .jsx to .tsx. So language, it was probably the most familiar to me. Routing is where we start to see some interesting option paralysis pick up. If you're using something like React Native, you need to understand, if I pick Expo, these are my set of options. And if I didn't pick Expo, I now have a completely different set of options. For instance, I picked Expo, so my navigation options were using something like React Navigation /native, which is a library that allows you to create different native screens and map those back to different components. So under the hood, it's using all of the native navigation controls that are provided by iOS and Android. But for me as a JavaScript developer, I'm just using those screens and all of these components to actually be able to map all of my JavaScript to the native presentation layer. Now, if I didn't go ahead and pick Expo at the start, there is another package that you could use called React Native Navigation. They are very similar in name. They are similar in functionality and approach, and I have mixed them up multiple times when talking about them, but they give you just different options. The React Navigation /native package is something that is vetted by Expo at the start, so that way when you go ahead and you build your app, because it's using some of those native dependencies, Expo knows about it ahead of time and can actually link up all of the native build steps needed for that. So if it requires some additional third-party packages, Expo knows about it beforehand and can link those into the proper build step. Other packages don't have that option. Now, I will mention that there is another approach you could do this with Expo, which is a file system-based router. At the time, this was still pretty early on and does have some bugs, but it also doesn't reflect a kind of dynamic approach that you can take with navigation. Having a file-based system, a routing system based on files is really great. It's good if you're coming from like something like Next and that is what you're familiar with, but it didn't necessarily make sense for me in this case, so I didn't use it. Pulling in third parties. Again, did you pick Expo? If so, your choice of third-party dependencies is really going to matter here. You could be looking for things like, you're going to have to look for some things that are said, we work with Expo right in their README, which can limit your choice of the pretty big ecosystem that React Native has. There's also going to be some libraries that are platform specific. So you're going to have a way to hook into those platform hooks that React Native provides and have separate components that only work with that one API. That can be pretty confusing and pretty complex and adds a lot of, now I have my iOS version and now I have my Android version. It really kind of goes against the whole cross-platform approach. And if you have any existing tools that you are familiar with or your team has kind of established on, you either have to pick different tools or figure out ways to make it work. So extra work on your plate. Native API access. Again, Expo is going to be influential here, but also will give you an option to say, I want to use a file system API. I'm just going to go right ahead and bring that in from Expo. There's also a huge list of core functionality that React Native provides out of the box for things like camera, for things like geolocation, and what have you. All of those features are provided out of the box, but there are some times where the community hasn't built the plugin for it. iOS just released a brand new API, and no one has built out an adapter for it. So if you need that and you're in that situation, unfortunately, you need to go ahead and build that out. Either in Swift, Objective-C, Java. I believe you can do Kotlin as well. But it does get back to the point where we're trying to move away from writing platform-specific code, but eventually you're still going to need to know some of it. So third-party native API access, hopefully there's an API for you. If not, you're going to have to familiarize yourself with that. And the process of going ahead and building these native modules is very complex, in my opinion. It's not for the faint of heart, and it can lead to a lot of cases that are pretty complex and confusing. Web deployment. There are two options here, depending on if you picked Expo. You have React Native Web and then React Native DOM. Both of these generate very unique DOM structures, I would say, where there's a lot of deeply nested divs to replicate whatever React Native provides out of the box, and you can get UI feature parity. Something that doesn't get mentioned a lot when you look at React Native Web is the libraries that you're picking and choosing inside of your pure React Native iOS or Android project. Because of those API differences, things like 3D renderers, file system access, more low-level controls don't always translate well onto the web. And so you're going to have a .web.js or .tsx file to then split your code base even more, which some people can say that's fine. We understand there's a difference, but it does drive home that this is not giving me the 100% cross-platform approach that I kind of was promised and I had hoped for. Now, so far I feel like I've been a little too negative on React Native. I will say there is a positive in here, and that is the debugging experience. You're familiar with your browser debugging tools. React Native integrates right with those. If you're using things like iOS, you can actually map back your JavaScript calls through the native layer to a Chrome DevTools and be able to inspect all of your components, set breakpoints in there, and have all that map back and forth. It's a really, really nice experience. And there's also a built-in on-device inspector that you can use to inspect your layout and see, why is my button pushing the layout or the UI down 20 pixels? Oh, it's because I had accidentally added a margin on there. And then for UI and design features, you're working mostly with either CSS and JS libraries that are specific for React Native, and inline styles. The inline style aspect, it is kind of what it is. There are CSS modules that you can use that make it feel a little bit more like CSS, but you're working also with a limited CSS capability. So things like background images, Flexbox is probably one of the bigger ones, are all a version of Flexbox that are fundamentally similar, but have some unique differences that separate them from what we know on the web. There's some really nice libraries that you can use out there. One is called React Native Elements UI/themed that provides a lot of those theming capabilities and actually gives you some components out of the box that provide more interactions than what you would get with a pure React Native experience. Again, those mimic helper functions from those libraries will mimic some of the web styles. So that was it for React Native. There are some downsides to it. There are some upsides to it as well. It's really all about what are you familiar with and what are you comfortable with. Considering this is an Ionic webinar, I'm going to assume that there is a lot of people are comfortable with Ionic. So I will kind of go a little bit faster in this part, but let's take a look at the actual app itself. So I'm just going to stop this server, and I'm going to come over here to my Ionic project. I'm going to deploy this to the simulator using Ionic cat run iOS dash dash live reload. It'll give me a set of emulators that I can pick from. It'll go ahead, sync all of those internal dependencies using capacitor and say, I'm using the file system haptics, keyboard, status bar. And before I even have a chance to finish reading, it has already launched the app. So much like the original project in React Native, we have a rich text editor here. So hello, webinar. Let's go ahead and save. We'll go back to that note. And in fact, let's add item 1, item 2, item 3, and we'll select those and actually make them items. We'll use bulleted lists for this. And then for the hello webinar, we'll make this an H1. And then we'll save. Oh, I accidentally hit delete. Oh, well. But let's take a look at the code for that. So this is an Ionic and Angular project, meaning that we are using Angular here as our framework of choice, bringing in a bunch of things like the core Angular libraries for component and signals. We're bringing in the file system APIs from Capacitor. And we're then going ahead and just working with the file system as if we would any other JavaScript library. So to make a directory, we're just going to call filesystem.makedir. Give it the sandbox that we want to operate within, and then the actual directory path that we want to create. To read it, we'll just do the similar approach using filesystem.readdir, giving it the same directory and then the path that we want to look at, and do a quick little sort of all of our files. Deleting them, delete file. Fairly typical tools in here, and pretty common naming conventions if you've done things with Node or any kind of shell approach to working with the file system. When we get to our edit page, we're actually using this third-party library called ngx quill, which is based off the quill.js module. It's going ahead, creating our data by getting the name that we want to read and then calling filesystem.readFile. And then we can set the content to this data. So all this fairly typical stuff that you should be familiar with if you've done anything with Ionic and Angular before. So let's get to our slides. So if you haven't heard of Ionic before, I'm kind of curious how you got here. But it's a UI library and native API for building mobile apps. We give you bindings for Angular as we saw, but also React and Vue. And all of these components and all of these UI elements are built on top of web components from the ground up. So if you need them in instances where you don't need a full framework, for instance, in an embedded context or a web plugin or web extension, you can actually use Ionic's components in there, which are pretty cool. And because it is all built on the web and the web runs more or less everywhere, you can deploy it to iOS, Android, as well as the web. So getting started is fairly simple. We install our global CLI. We then start a new project, pick our framework of choice, and then go ahead and deploy this to the simulator. It is really that easy. It is exactly what I did when I started this project, right into the simulator from a fresh project install. So really smooth onboarding process there. Language is all TypeScript from day one. We even bring Vue and React into the TypeScript ecosystem. All this because we know that with larger, more complex projects, TypeScript is an essential thing that you need. There's really I think we've seen a lot of commentary with certain projects getting rid of TypeScript or moving away from types. If you've been on any large projects, you know how helpful types are and how helpful it can be to know the entire structure of your APIs before you even go ahead and run anything and get any runtime errors. Routing. This is one where we take a different approach depending on the framework that you are using. We do have the integration with Angular's router, Vue's router, and React router. But what we do is we build on top of that to create that stack navigation that we saw in React Native, but also that comes from pure native navigation. So that stack navigation means that we can have multiple navigation instances with separate routing histories between them and make sure that those are maintained regardless of where you are in your app. So tab navigations is a perfect implementation of this, where tab A could have page 1, 2, and 3, and tab B could also have page 1, 2, and 3. And those navigation instances will not conflict with one another. They also provide a lot of animation and transitions out of the box, so you don't have to wire up anything for that. You can customize it if you want, but all this stuff is out of the box provided for you. Third-party libraries. Because Ionic is built with the web, you get all access to all the features of NPM and all the libraries that exist out there. You can use a pure JavaScript library if you would like, or you could find TypeScript-specific ones that give you all the type information that you need to make sure that you not only are you familiar with it, but your team and anyone who works on your project in the future. It can be familiar and functional with that library. Now, I will say not all libraries are going to be the right choice. There are cases where there are libraries that are very specific for large desktop environments where they have nearly infinite CPU access. There are libraries that make sense first as a mobile first library that then can adapt to more powerful contexts. A really good one is a charting library that exists out there that doesn't really work well on mobile, but works great on a desktop. Where there are alternatives to that library called C3. C3 is a very lightweight and fast charting library built on top of D3 that gives you specific charting APIs that are great on low-end devices, but also work great on desktop. So evaluate what libraries you are using and make sure you're just picking ones that are great for mobile performance. Native API access. I mentioned it quickly. It is provided through this library called Capacitor, which is one part a native runtime and one part a native API bridge. So you can have your web app rendered inside of our Capacitor runtime. And then within that runtime, you can then access things like the file system, Bluetooth, NFC connectivity. All of those things are possible through Capacitor. There is an extensive community library. We have our own Capacitor community organization on GitHub. There's also another one called Cap Awesome from a Ionic developer expert, Robin Goetz. He has built a lot of things for vision and machine learning for vision ML, as well as a pretty awesome NFC scanner. So really cool things. All of them are available. But if there is an API like in React Native, if there's something that you want to add that isn't available, you will have to write a native plugin for this. Now, the only thing that I think separates building a React Native module and a Capacitor plugin is that the Capacitor plugin is actually much simpler to build. I do not have an extensive native development background, but I was even able to build something with Capacitor's API. Now, the way it does it is that it doesn't need to be packaged as a plugin right out of the box. You can use a separate file that just exists inside of your native project, and then you have a thin wrapper of JavaScript that just maps those calls back to the either the iOS implementation, the Android implementation, or the web implementation. Versus React Native, which is a little bit more of a involved process. Now, the web deployment story is very, very straightforward because it is just web technologies at the end of the day. You're just writing HTML, CSS, and JavaScript, so deploying it to a web hosting provider of your choice is very, very easy. When you get into the details of how you're accessing things like native device features, platform-specific features that exist on iOS or one platform or another. There are ways to work around that where either the plugin author can reject uh, a an implementation and say, "Hey, this is not available on the web or it's not available on iOS," and just reject that promise. Um, Other implementations include providing your own sandboxed implementation. So if we were to go to, say, our notes taking app over here, right? We have the same app up and running, and I say, hello, save. If I were to open up our dev tools here, like what do we have that is actually running the back end of our file system over here? Well, we actually have an IndexedDB instance, which is going ahead and mimicking a full file system operation. So we can get all the documents, we can get all the path, we can get the contents of those of that file written right into it, instead of having to worry about, okay, am I accessing the actual file system or just a emulated file system? The implementation doesn't necessarily matter, and the capacitors plugins allow you to swap out the implementation without you having to worry about the API that you are writing with. Tooling and debugging. If you're building a web app, you should be familiar with the debugging environment inside of a browser. So you're using things like Chrome's DevTools, Safari's DevTools, or Firefox's DevTools. Adding on to it, each framework kind of provides their own specific DevTools that allow you to inspect not only the component tree, but also the component state. For instance, if we come over here, I am going to just open up real quick Chromium browser. And inside of it, I have the Angular dev tools, and I can see not only the component tree, but if I come into, actually, let's look at the actual app component. We can see I have all of the notes, which are going to go back, give me insight to the lower level details of the framework if I need it. You can do this not only inside of the browser, but also remote debugging from your actual device, which is super helpful. So if you are trying to debug something that only exists on a on device, you can still have access to all of those tools. And then live reload when you are on a device is such an essential feature to have. It is very nice to know that it is the same experience that I could have up and running in, say, my simulator over here. If I were to get rid of this, do quick little window management, all of these things are talking to the same host provider. And not only can I have the debugging or the live reload on device, on my simulator in the browser, I can have it running on Android as well, and all these things just work together perfectly, which is super, super nice. UI and design features. Obviously, Ionic provides a really, really good component experience. All of our components out of the box try to match as close as possible as we can to native iOS and native Android controls, and still allow you to hook into those components and customize the look and feel for everything. So if you have very strict guidelines on branding or how your components should look and behave, we give you the hooks for that, so that way you can integrate into that those styles into the overall feel of the app. Theming can be done either at a global level that happens throughout the entire component tree, or on a component by component basis. And it's full CSS all the way down, which is pretty great because CSS has gone through some pretty extensive improvements over the years. So we have things like nested selectors, color mods, the has selector. All these things make CSS much more compelling than it had been in past years. So this is Ionic in a nutshell. I didn't spend too much time on it because hopefully you should all kind of know how Ionic works and how it compares to other tools. But this is all of everything in a nutshell. It is a very, very great platform for building mobile apps. Now we're going to look at one more before we wrap up, and that is Flutter. Flutter is kind of, I wouldn't say it's a new kid on the block, but it is something that has been popping up more and more. Funny fact, Flutter is actually created in 2015, 2016, so it's actually a lot older than most people give it credit for. But what we're going to do is actually just go over to my IDE, and then I'm going to open this up in another terminal where I'll just say Flutter run. Now we'll have our simulator up and running over here. You can see, let's go to the simulator. You can see it said, hey, we have a couple devices that we can deploy to. Which one do you want to pick? It'll go ahead, compile not only our native app, but also going to compile the Flutter specific code that we're going to look at. So we'll do a quick little window management. Instead of here, we can say, look at our first note, look at our second note. We can look at the actual code to do this. This is Dart. We'll go over Dart in a moment, but more or less all this is bringing in some dependencies that we want to use and some third-party packages. We're creating our main instance of the app, which is using this homepage and then this material app theme. And then we have this entire concept of a stateful widget, where anytime state changes inside of this stateful widget, we're just going to go ahead and re-render our page or our UI that we want to display. Now, our UI is going to hold all of the actual functionality in here, where we can set up our state based on this state class that we are extending, our file system, where we're calling this file system makedir and then get files. And then our files are just calling that same functionality from the file system wrapper, readdir, and then setting some notes. Now, actual implementation for the UI is a little bit more different from React Native and Ionic, where all of this is using components in this widget tree. And I'm going to zoom out just a little bit to make sure that all this comes into focus. But you can see we have our widget tree, which builds out an app bar, an icon, and then an on-press action where we can say, go to the edit screen and push in any context that we might have there. The rest of the actual UI that we have is this list view where we can say, hey, I'm going to have a list of notes. And inside of that, we're going to create a list tile, which is just a list item in Flutter terms. All this is going to go ahead, and when we click on one of them, we can go ahead and see that note in the editor detail, which we pass along here. Now the editor widget, we're going to kind of jump through that because we are close on time, but all the stuff in the editor page is more or less the same. We are just pulling in file system APIs and this third-party library called Quill.js again to render out this UI for interacting with rich text. So let's get to the slides and kind of look at how this played out. Flutter, in a nutshell, is another open source framework provided by Google. They originally built it for some operating systems and then open sourced it to allow other folks to build mobile apps with it. It's written in Dart, which we'll look at in a second, which is a pretty interesting language. But the one thing that I think gets overlooked really is that Flutter is actually using a fully custom renderer for all the UI. So all those buttons, all of this that we are seeing here is all being rendered through a custom renderer. And out of the box, it gives you support for iOS, Android, and web. and including desktop in some cases. Now, to get started with Flutter, you just install through Homebrew on a Mac, so I'd used Homebrew, and then I said Flutter create and gave it a directory name. From there, I had an app that was created. I said Flutter run, and then it deployed to my simulator. What's really nice here is that Flutter's out of the box experience gives me a stateful widget, so I could see how I could interact with some state inside of my component and how to start making modifications to that state. So that way I wasn't lost in the getting started experience. It was just there. I could see how changes were being made and how my app would update. Now, the language itself, Dart, it's not as bad of a language as I think I assumed going into it. Dart is actually a pretty cool language. It was familiar enough for me as a JavaScript developer to feel like I could get up and running. And if there were any common mistakes that I made, there is a lot of tooling in place to make sure that, hey, I see you declared a variable, but this variable's value never changes. You should probably use something like final to say that this value is set in stone. And other cases where it said, hey, we'll fix all the importing, we'll fix all the formatting, we'll basically make this look like it was completely rewritten, which is really, really nice. Dart as a language is a really, really interesting language. And, I feel bad for not paying attention to it a little bit longer. But it does provide a lot of cool things and it can be familiar if you've come from Java as well. Now, Flutter, what it does for routing is actually create a full navigation instance at that top level for you out of the box. You don't have to create any routes or any config for all those routes. All you have to do is say, hey, app, I want to display this component, push it onto the stack. So it's following much more of that native paradigm where anything and everything can be navigated to and routed to. Third-party libraries are where it starts to feel a little bit weird. Basically, everything is a package inside of a Flutter app. There is a core runtime in the core component list, but if you want to start interacting with things like XHR and HTTP, Firebase, SQLite, you're installing dependencies. And they all come from this package repo called, or this package registry called pub.dev. Now, what's unique about Flutter and how they approach this is they have what's called, well, I call it first third-party packages, where they're maintained by the Flutter team, but they are not provided for you out of the box. So to do anything with third-party libraries or even native libraries, you need to install a package to get started with that, which feels a little weird, but I guess it does allow you to remove extra utilities that might not be needed. Native access, again, follows that same approach that third-party libraries do. If you need to access anything, you're installing it from pub.dev. And all of these packages are actually making use of the Dart runtime to actually get their functionality done. You're not necessarily hoping that there is an API out of the Flutter library. It's all coming from Dart, which is really the unsung hero. Flutter is just a renderer and the UI widgets. Now, if there is a package that you want or a native functionality that you want to add, but there is no package in there, you're going to have to build one of those. And I think this is where you might see the biggest drop off, is that to write packages for custom functionality, you need to actually write in C and C++, which I don't know if folks in the, leave a comment in the chat if you've written C before. It definitely is not writing JavaScript, nor is it writing Objective-C, Swift, Kotlin, Java. It is its own world, and once you touch C, C++, things get very, very complicated very, very fast. Now, the web deployment story does have a little bit of a silver lining, but also some caution. You can render things in a Flutter app and deploy it to a web. to the web, but you're using some interesting approaches to do so. All the rendering for that, you have two options. One is doing things kind of in a light mode that they call it, where you're using web components to render stuff out. Or if you want the full fidelity, you can use this WebAssembly approach, which uses a bunch of canvases to render out all of your UI. Where that kind of breaks down, though, is accessibility. Canvases are unaccessible or inaccessible by default. So with everything being rendered to canvas, there needs to be extra work put into place to make sure that your app is accessible for folks who are using keyboard controls or voiceover, what have you. Ionic has that kind of out of the box. Even React Native has that because they are using native controls. Flutter's web deployment doesn't actually get us all of that. That's because it's using Canvas in those cases. That might seem like it's a little bit of a downer, so let's kind of bring it back up with some of the tooling and debugging experience. This is really, an amazing feature of Flutter, is that your editor integration and the tooling support that comes with building a Flutter app are actually really, really good. Where some cases where, like I said at the beginning, you are not redefining variables or redeclaring their value, Flutter will go in and say, hey, we can rewrite this and do code mods. It's not necessarily the same as saying having a linter, but it's having a full static analysis of the libraries and the code that you're using. If there's things like errors or any time like you make a mistake or a runtime error, it'll point you exactly back to where that error caused, and not only the line number, but the file where it's at, what the actual stack trace is, right inside of your console. So you have deeper understanding of how these errors pop up. Things that we also have in the web and inside of Chrome DevTools, Flutter has that also. They have a widget tree to inspect the actual stack of your components. They have a memory management tool and then a networking tool. So you get a familiar environment to, say, your web debugging experience. Just all done custom for Flutter and the Flutter renderer. UI and design features. Flutter does give you some components out of the box. It doesn't give you everything that you might want, but it'll at least give you list items, some cards, some buttons, basically the bare bones of what material design has said are core components. All of those components are essentially just raw building blocks that you then have to build on top of to create the finer interactions that could exist inside of your app. Like if you didn't notice in the Flutter app over here, there's no swipe to delete as we had in, say, the Ionic version or the React Native version, because that just doesn't exist inside of Flutter's component library. That would be something that you would have to build extra. And all of those extra functionality and all that extra components are all dependent on the Flutter runtime. So if Flutter actually decided to change how a component works, which they can do because they own the whole rendering stack, you now need to go back and actually update that component to match the new implementation of the runtime or whatever material says that you get out of the box. And if the sight of material design on iOS is a little jarring to you, it's jarring to me as well. Their way of approaching this, of having a material app, can be customized. So that way you could have something like what they call a Cupertino app, an iOS Apple design. But you end up having to create multiple instances of having, if platform is iOS, use the Cupertino design, and if material, use the material app. There's no kind of unified approach to doing that out of the box. So one last note on all of these. What really stands out to me is, in the cases of working with React Native, Ionic, and Flutter, if there's ever a place where I feel like I'm at a large company and I need some help, I mean, React Native's owned by Facebook, Flutter is owned by Google. They don't actually have dedicated support. Ionic does have dedicated support, so if you need that for your large team, that could be a very good reason why to pick Ionic. But I will say across all of them, building the actual app itself and focusing on the technology of it, these cross-platform tools are actually a lot similar than people might give them credit for. All these tools are there to give you a leg up in building those apps. So there's really no one way that I could tell you which one you should pick. I would highly suggest building amazing apps with them, trying it out, and understanding where are your team's needs and what do you actually need to build today. Because all these platforms and all these tools are capable of building great apps. It's really up to you to figure out, do I need this? Do I need that? Or do I need this? And then by building with all the building that app and evaluating it, you should have a better understanding of what tools that you should use. It's a lot easier to say that than for me to be like, you should only use this. Evaluate it for yourself and understand how those tools can fit into your organization. So I'm going to take a few questions right here. If you had any of them that popped up during the presentation, please drop them in the Q&A. Let's take a look at what we got for chat and Q&A. I see a few people. Let's see. Kent, I hope you put your question inside of the Q&A. So let's go through this real quick. All right, we have a question from Mike Purdy. Does Ionic have any plans to allow Capacitor to target desktop deployments similar to Electron, but from within a Capacitor project? At the time, I don't think we have anything concrete. We do have some community efforts to do things with Capacitor Electron, then as well as Capacitor, I think it's called Tauri, which is a different approach. But nothing set in stone and nothing that we can like share on right now, but keep an eye out for the future. Daniel Craig wants to know, what can I view console messages in VS Code? Yes, you can with both Ionic and Flutter. If you're deploying it through VS Code, all those console messages would come up inside of the terminal. Dimitri, I would be interested in your personal opinion about NativeScript Capacitor. It was released some time ago, but I don't hear a lot of comments on it. Yeah, so NativeScript and Capacitor. Yeah, that was something that was released by the NativeScript team for folks who wanted to use both NativeScript and Capacitor in their projects. Why I don't think it's, gotten some adoption, mostly because it does involve a lot of work that is platform specific, where Capacitor's API allows you to write things in a way that is cross-platform. NativeScript does have an approach that gives you full access to the raw underlying implementation, but doesn't always feel as cross-platform as it could be. I just don't think it hits the mark, and that's my own personal opinion. I will note I am friends with the folks over at NativeScript. Nathan Walker is a friend of mine, so I think they're doing a fantastic job. But yeah, personally, I think it kind of deviates from the goal of what cross-platform development should be. There's one in the question. Okay. Will there be a video of this when it was done? Yes, there will be a video when this is done. It'll be presented and slides will be available. Is it possible to integrate a Capacitor.js app with a Next.js app while also retaining Next server-side rendering? That is a very good question. I know we've had some demos and examples of using Capacitor and Next.js together, mostly using Next.js as a static output. I don't think it would work in a case where you have the server-side API or the server-side rendering inside of the Capacitor app. I think you'd probably have one point pointing to the server-side rendered version for the web app, and then another approach using the statically generated version for your capacitor app. But I'm not a Next.js expert, so I would say do some experiments. I would actually be curious to know. So definitely take a look at that. Um, Really, really good one. How is the animation performance these days with Ionic and Capacitor? Animation performance is very, very good. The two Ionic provides all those animations out of the box that are not only hardware accelerated, but keep a consistent 60 frames per second. So your animations can be buttery smooth. There is a list of if you're seeing any performance issues, there might be cases where you are animating the wrong things. There is a very good site called CSS Triggers, which allows you to see if I animate, say, margin left, will that cause any stuttering or any performance impacts of your, are there any performance issues with that animation? So check out CSS Triggers if you're seeing any issues, but out of the box animations are super, super smooth. All right, we are a little bit at time, and I know there are a bunch of questions in here that I can't get to. So we'll get to those, and we might reach out to answer some of these questions. But thank you all so much for joining. I hope you've enjoyed this. I've certainly have found this to be pretty fun. So hopefully we'll get to do these again. Hopefully I'll get to do these again in the future. But thank you all for joining. Take care.